All right, good morning. Welcome in Friday, October 7th for another safety focus of the week. This week's code of conduct is to drive safely, defensively, and courteously. One of my favorite code items. I see Mr. Dow is with us this morning. Is there anything you'd like to add on our code item this week?
Yeah, if when you're trying to do the merge on Williston Road and you're in an ECI vehicle, sometimes it's good to just let them win. Don't get in a race.
Yep. It's definitely our most vulnerable loss control on regarding driving incidents and phone calls.
Yeah.
For sure. So yeah. All right, Austin, next slide, please. Excellent job last week. Again, starting off Q4 strong, another 7 days without a recordable. Up to 110 days. Again, it starts with pre-planning, really thinking about our tasks before we do them. And again, that's that JHA. Getting started, communicating, filling out that JHA with a hierarchy of controls in mind, trying to eliminate and isolate all of our potential hazards before we get in to our work environment, and making sure that we got all the right tools and equipment and PPE needed to do the job safely in the right way. With that said, Austin, I'll pass it over to you for the topic of the week.
All right. Come on. All right. I'm going to talk a bit about suspended loads today. Essentially, anything that is lifted above the ground is going to be considered a suspended load. And you need to understand the hazards around them. Accidents can be pretty serious and fatal. When you drop a heavy load, it's gonna create some big issues. So be aware of all these different hazards and steps I'm going to talk about. First thing, check for overhead power and utilities. Know your minimum clearances between the crane and the line. Up to 50 kilovolts, 10 feet, over 1,000, you got to contact the owner of the power and talk to them. Again, check the load rating of your slings before you're even starting to lift anything. Again, they're going to be marked with a tag. Here's a few different examples, and if there's no tag, just don't use that lifting sling. Be aware of any pinch points that can come up when lifting up the item. Can it swing and catch you between something? What's going to happen when that item is lifted up? Is it going to create a hazard for anyone in the vicinity? Mark or barricade the swing radius of the equipment, whether it's a crane, an excavator, anything like that. Mark, tape it out, barricade it, put up cones if you can, just to show where that's gonna swing, and so people aren't caught between things and caught in pinch points and things like that. Ensure your load is correctly balanced and secure. As you're starting to put weight on it, make sure everything is looking tight and whatnot, and if it's not, set it back down, redo the rigging. Make sure that everything is balanced, and also make sure it's secure. Make sure nothing's gonna fall off it, or slide off and hit someone, things like that. And when you begin the lift, make sure no one is under a suspended load, and keep everyone clear of the area when the load is in motion. Make sure you have a trained signalman who knows and uses the standardized hand signals, and they must have unobstructed view of the operator, a clear view between the two, and never allow multiple people to give hand signals unless you see something that the signalman doesn't, and you can stop the operator. A horn shall be used when the load's in motion. Again, an air horn just to warn people around the job site. A lot of equipment has, beepers when it's in motion, and never leave a load suspended in the air. Never just be like, oh, hey, we have this thing that's in the way right now. Let's pick it up for a bit and get it out of the way. Don't do that. So those are a few things to think about when lifting loads. And Matt, do you have anything to add?
Yeah, one thing that came to mind actually was one of our tip overs that we had a couple years back, and one of the manufacturer's recommendation for proper testing a load, a quick test pick, is lift the load 2 inches above the ground and rotate 90 degrees. And that was kind of more for the excavators than the cranes. But I thought that was interesting and something to highlight. Again, we should always be doing a quick little test pick and checking rigging before we sling anything in the air, if it's a trench box, if it's any of our construction materials. Just really make sure that we're in doing our daily inspections like Austin highlighted, and then good safe practices with making sure that nobody is ever underneath a suspended load. Thanks for the presentation this morning, Austin. And
all right, thank you.
I'm going to share my screen. Does everybody see the weekly email? All right. Announcements. Cooler weather is coming. It's time to start using diesel fuel supplement. Again, that's the white container. We have 2 new hires to welcome to the team, Hussein Saadi and Chad Stillwell. Hussein is a member of the civil group, and Chad is going to be a CDL truck driver driving the triaxles. So welcome aboard, and if you see them, introduce yourself so you have a nice warm welcome to the ECI family. October is Breast Cancer Awareness Month, so join the ECI to support the UVM Medical Center Foundation. Go see Sarah regarding any pink shirts. We also have sweatshirts with a pink ribbon in the back. Again, this is a fundraiser that we're doing, and all the proceeds go to UVM Cancer Foundation, and then check with Sarah again. I believe the shirts and sweatshirts are $10 a piece. It's a really good fundraiser they're doing, and also you get a nice shirt and your sweatshirt out of it. Again, just highlighting the ECI employee personnel loan program. We talked in length regarding this last week. Again, check with Ursula or Andrew up in admin if you want to jump on this really good program that we're offering as an extended benefit to all employees. Ken's coming back today because he was down in National Harbor, Maryland. ECI, we co-authored a technical paper on the anchored hollow bar tangent pile system for underpinning for Deep Foundation Institute of 2020 annual conference. Here's a photo that was taken and probably by Ken. It was our technical paper, and presentation was on hollow bar underpinning at the Brattleboro Memorial Hospital that was completed in the winter of 2021. Our consultant Marco presented the paper. Here's a link to that paper if anyone wants to read up on it. That's actually, I kind of was reading it a little bit before. It's very interesting and educational. The Deep Foundation Institute is a trade associated for contractors, engineers, and vendors in the industry related to deep foundations regarding to driving piles, drilled piles, etc., ground modification, earth anchors, excavation support system, and shoring systems. Job well done. highlight again the ECI Primary Care Wellness Program. I've talked to a couple individuals in the last couple of weeks regarding jumping on this. Again, it's definitely a very good benefit for all employees to take advantage of. If you're already in the program, our annuals will be coming up soon, so put that on your radar, especially on good rain days, or if a day that you get out of work a little early and you want to jump over there, just contact Health and Safety, and we'll either get you in the program or make you make your visit for the annual physicals over there. We're going to bring in Phil now. Phil, for the job of the week, we're going to highlight the bridge rehab precast construction in the backyard.
Yep. Sounds good. You can scroll down to a photo if you want, or stay right on the text either way. All right, ECI was contracted with VTrans on the Clarendon Wallingford VTRY and the Manchester VTRY projects. These are two separate railroad bridge rehab contracts that involve 8 different bridges and 14 individual precast components on the Vermont Railway. The scope of work for these projects included replacement of the abutments and back walls with precast pieces, substructure rehab, structural steel replacement and strengthening, bearing replacement, bridge deck work, approach track work, abatement, and painting. This week's write-up is focused on the precast substructure production, which ECI elected to self-perform. Abutment, bridge seats, and back wall replacement work takes place during a very limited and predetermined weekend work windows, much like the one we've got in Manchester this weekend. Due to the short duration of these work windows, casting components in place was not an option. ECI had the ability to choose between procuring the precast manufactured at an NPCA certified plant or building it ourselves. With the long lead times that precasters were predicting, ECI and ECI's desire to complete these projects during this calendar year led us to make a decision to self-perform. Producing a critical path material in-house also had the added benefit of maintaining a further degree of control over the project. I'm sorry. The accelerated schedule required that fabrication drawings be completed simultaneously in-house and by a hired outside engineering firm for the different bridges. ECI detailed bridges 89 and 93, while Calderwood Engineering detailed bridge 71. These drawings show the configuration of various pieces and detail rebar placement and lifting and bearing anchor locations. ECI was responsible for the erection plan for all precast on this project. However, Calderwood did do their own lifter design. Much like Austin was just talking about with lifting loads, attention to detail is crucial at this stage because existing conditions and geometry affect how the pieces are shaped, will fit together, where the lifters will be placed, and how level they will pick for transportation and installation. The configuration, elevation, grade, skew, and relative dimension of the bridge bearings, rail elevation, and the existing substructure all must be compatible with the new work. The lifting and handling plans considered rigging angles, equipment capacities, lifting anchor limitations, and structural integrity of the pieces, which range in weight from 3,000 pounds to 36,000 pounds. While some of the precast is simple, some of it was fairly complex. The Bridge 71 substructure units are a combination of abutment, back wall, wing wall pieces. These have sleeves for anchor bolts, which connect the units to the portion of the existing abutments to remain, as well as for the new bearing anchor bolts. The layout of these components is critical. ECI opted to pour this monolithically, using the sleeves as a convenient conduit for coil rod hold downs to keep the top forms over the lower portions of the seats from floating during the pour. Fabrication of all 14 pieces was fully completed by a team of 2 to 3 people within 45 working days of receiving the approval to begin fabrication. 4 pieces have been installed to date, with an additional 6 pieces being installed at this weekend shutdown in Manchester. So if you scroll down, here's a design fabrication drawing done by Calderwood Engineering that shows all 3 of the pieces that they're identical for both abutments in Manchester that will be installed this weekend. The anchor bolt locations, all detailed here with lifters as well. Here's a cross-section view of the piece. If you scroll down, you can see the level of detail that went into the drawings and then also into the pieces, with having to avoid conduits and rebar and making sure everything works well together. This the next photo down is that form all closed up. It was a monolithic pour, which was fairly difficult because we were using self-consolidating concrete, and because of that, pouring a wall required a fairly large surge board at the bottom for the bridge seats. Here's a picture of the guys working out back that had spent a couple days forming it up, and we're getting ready to pour. And here's the finished strip piece that looks very similar to the fabrication drawings up above. This is another piece for bridge 93. This is an approach slab back wall piece with, they're all fairly identical, except for the various wing wall lengths. And here it is in cross section again. And then this is one we had done in-house. So these are our drawings. And here's Jack and Todd working on the walls that were poured 2 days ago, actually. It's the last pour for this project. A couple of pictures further down show the cast in place corrugated sleeves that the anchor bolts will then be drilled through to pin these pieces down to the existing abutment. And then we see the lifting anchor and dog bone inserts that will then be used to both pick these pieces up and also tie them together later on when we set them next to each other. The next plan down is our lifting plan. A lot of detail goes into these to make sure that the rigging angles are appropriate for the rigging that we use and for the lifters. So it's not just maintaining proper angles on the rigging, but making sure the lifters don't pull out of the concrete. And all that is detailed right there. And then it's always nice to see that pan out exactly as you had drawn it in the field, with this being a picture of us picking the first piece. Further down. Again, like Austin was saying, very important that these pieces pick level. You have different elevations between the wall and the seats. And so rolling blocks is a nice way to make sure that your the pieces are, the anchors are equally loaded. And here's a close-up of that further down. Piece just floating a couple inches off the air. That was our test pick. Make sure everything works. Nothing shifting out of place. And then further down, here's another example of that. This was our back wall for Bridge 89, which is currently in place, and we'll go over that next week. And if you scroll right down, you can see that that's our spreader beam, the synthetics, just like we detailed, and the piece flying nice and level to be loaded onto a truck.
Very
Then
professional looking, very professional.
And then photos from the archives. It looks like it was for Bridge 130 in Cavendish in the fall of 2009. Believe that's Kevin, and is that Ron with a mustache in the back?
I think so, yeah. Looking great.
Very nice.
Yeah.
But definitely something we've been doing for a while. Precasting in-house is definitely can save us some time. It is nice when we can do it ourselves and have a little bit more control over the schedule and the product.
Indeed. Thanks, Phil, for jumping in and talking about this week. The highlight of the week, this project. With that said, let's have a real safe day. Looks like the weather will break mid-morning, late morning. So hopefully we see that sunshine this afternoon. Let's have a great day. Let's have a safe day. Again, let's start off today with a nice safety briefing about our hazards and how we're going to control them. With that said, let's have a safe day. We'll talk. Give health and safety a call if you have any further questions. Have a great day.